What's up, everyone, and welcome to today's math class. The title of today's lesson is on the screen. We are going to use the coordinate plane to calculate area of polygons. So a couple pieces of equipment you may want today. A calculator could be useful, of course, pencil and paper. And you may, if you have access to a printer, you may want to print yourself out a couple of blank coordinate planes. I'll leave this PDF available on Brightspace. That way you can access it. But you can print a couple out. That way you can actually plot the polygons that we are working with in the coordinate plane. And of course, because we are going to eventually calculate area with all those polygons, your formula sheet is always your best friend during this unit of study. So make sure you have access to it as well. All right, so area on the coordinate plane. So essentially a four-step process we're going to complete to calculate area on the coordinate plane. Step one is once you've plotted all the points in the coordinate plane, you need to identify the figure. What shape are you dealing with? Is it a rectangle, a square, a trapezoid, a triangle? Identify the figure. And once you know what figure you're working with, you can use your formula sheet to find the appropriate formula. If you're calculating area of a square, A equals S to the second power. Area of a triangle, A equals 1/2 BH, and so on. So we are copying down the formula we need to use to find the area of the polygon on the coordinate plane. Then you're going to use the coordinate grid to find measures of that figure. If you have a rectangle plotted on your coordinate plane, you'll want to find the length and the width of that rectangle because those are the two pieces of information you need to calculate the area of that shape. If you've plotted a triangle, you'll need to count and find the base and the height of that triangle that's plotted. Once you know those measures, the last step is like what we've been doing all week long. We are going to substitute those measures into the formula in order to calculate the area of that shape. If you'd like to copy down these four steps, pause the video, record them in your notebook, and then hit play again to do some examples with me. All right, so our first object is up here on the screen. We are going to find the area of triangle ABC. So step one, identify the figure. We know this is a triangle. So from your formula sheet, if you need to pull it up, our formula for area of a triangle, area equals 1/2 BH. So we're going to copy that formula down first. Area equals 1/2 BH. Well, B is the base of the triangle, so I need to look at this image and find the base. The base of this triangle is actually this line segment at the bottom, AC. So I need to find the measure of this, and the easiest way actually to do this is to just count how many units AC is. 1, 2, 3, 4, 5, 6, 7, 8. So AC has a measure of 8 units. So I know that my base is going to equal 8. Now our height. The height, if you remember in a triangle, is the measure from the base, which is line segment AC, to the opposite vertex. So I need to get up here to B. So if I'm counting the height, it would be 1, 2, 3, 4 units tall. So I get a height of 4. Once you've used the coordinate plane to find those missing dimensions, all we need to do is substitute these values back into our formula to calculate area. So we have 1/2 times the base we said was 8 times the height. We're going to substitute in a 4. And now 1/2 times 8 times 4. Grab your calculator if you need it. You should get 16. Now, we don't know what unit is being used to measure these dimensions. So in that case, we're just going to use a generic term. The area of this triangle would be 16 square units. All right, our next example, we have quadrilateral ABCD on the screen. Let's find the area of this together. Step one, identify the shape. This is a quadrilateral. I see that opposite sides are parallel, so we actually have a trapezoid. So my next step is to find the formula for area of a trapezoid. Pull out your formula sheet if you need to. Here's the trapezoid in the top right-hand corner. Formula for area, 1/2 times h times the quantity of B1 plus B2. So copying down our formula, area equals 1/2 times the height times the quantity of B1 plus B2. All right, let's look for our bases. Remember our bases, B1 and B2. those are the two sides of the trapezoid that are parallel to each other. So the first parallel side here is BC, and I see it has a measure of 1, 2, 3, 4 units. And then B2 would be the opposite parallel side, in this case line segment AD. 1, 2, 3, 4, 5, 6, 7, 8. And then finally, for our formula, we need a height. The height is the distance. How far apart are these two bases? 1, 2, 3, 4. I get a height of 4. Now I'm substituting these values into the formula. Area equals 1/2 times the height is 4 times the quantity. Base 1 is 4 plus base 2 is 8. Close that quantity. Now use your order of operations to simplify your formula. Grouping symbols first. 4 plus 8 is 12. Area equals 1/2 times 4 times 12. Performing that multiplication, 1/2 times 4 times 12 gives us an area of 24 square units. All right, I'd like you to try this one on your own. We have triangle IJK. Find the appropriate formula for this polygon. Find the missing dimensions. Substitute those dimensions in to calculate area. When you're done calculating your own area, begin playing this video again to check your work. Okay, here we go. Formula for area of a triangle. Area equals 1/2 base times height. Area equals 1/2 times the base of this triangle, IJ. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the base is 10. And then the height would be over here. Line segment IK. It is 1, 2, 3, 4, 5, 6, 7 units. Performing my multiplication, 1/2 times 10 times 7 gives me an area of 35 square units. All right, one last thing to do with area on the coordinate plane. Sometimes you won't be given a plotted shape. Instead, you'll be given ordered pairs that represent the vertices or the corners of that polygon. So you'll need to graph that object first and then use the information to calculate the area. So let's go ahead and graph these points together. Grab a coordinate plane if you need to, or make one on your own. We're going to graph an ordered pair at 3, 2, so 3 to the right and up 2. So there's 3, 2. And then our next one is at negative 4, 2, means from the origin we are moving 4 to the left and up 2. 3, 2 means 3 to the right and down 2. So moving 3 to the right and down 2. We're in quadrant 4, plotting our point. And then finally, negative 4, negative 2 means 4 to the left and 2 down. Let's go ahead and connect those vertices, and we should get a rectangle. So to calculate area of a rectangle, if you need to access your formula sheet, pull it out. Rectangle is the second object in the left-hand column. Formula area equals length times width. So let's go ahead and copy our formula down. Area equals length times width. Let's say the length is this distance across the bottom. It is 1, 2, 3, 4, 5, 6, 7 units. And then the width, 1, 2, 3, 4. So the rectangle 7 by 4, a length of 7 times a width of 4. 7 times 4 gives us an area of 28 square units. Cool? Great. All right, last one for you to try. Find the area of a figure that has vertices at negative 4, 1, 1, 1, negative 1, 5, and 4, 5. Plot your shape, calculate the area. When you're done, come back and check your work to see how you did. All right, let's start by graphing our points. Negative 4, 1, 1, 1, negative 1, 5, and 4, 5. All right, connecting my points, we have ourselves a parallelogram. Formula for area of a parallelogram from your formula sheet if you needed to look it up. Parallelogram down here on the bottom left corner. Area equals base times height. The base is across the bottom, 1, 2, 3, 4, 5. times the height would be then the distance up to the opposite side. 1, 2, 3, 4. Calculating our area, 5 times 4 gives us an area of 20 square units. Boys and girls, please complete your independent practice assignment on area in the coordinate plane. Take a picture of your work and upload that file for submission. I'll see you guys next time.